Good morning. Welcome to lesson 7.6, cross product of two vectors. In today's lesson, we're going to be looking at another type of multiplication with vectors. This one is called the cross product. So I'm taking two vectors, A and B, in 3 space, and the cross product will be the vector that is perpendicular to these vectors. Now we know that there's many vectors that are perpendicular. This is going to give us one vector that's perpendicular. So here in the picture you can see here are my two original vectors A and B with an angle of theta between their tails. When I do the cross product, the result will be this vector A cross B, which is perpendicular to both A and to B. So it kind of sticks off in a different direction. You might recall that yesterday when we were doing dot product, we did a similar question where we found a vector that was perpendicular to both A and B. This is going to be one single operation that will give us that vector. So how does it work? If I have vector A with components A1, A2, A3, and vector B with components B1, B2, B3, then A cross B is going to be this rather complicated arithmetic string here. And so to come up with the first component, the x component, what we do is we take A2, multiply it by B3, and then subtract A3 times B2. That's going to give us the x component. And then just the y, I'm going to do A3 times B1 minus A1 times B3. And then to get the z, we'll do A1 times B2 minus A2 times B1. So a rather long string of arithmetic to get to our answer, but it's a rather simple process. If I were interested in this angle between A and B, I might use this formula here. This is for the magnitude, so I might also use this formula here if I was interested in only the magnitude of A cross B, and if I knew the magnitude of A and the magnitude of B. So I might use this formula here if I was interested in one of these bits. If I was given this information here, then I wouldn't have the sign of theta, but I would be able to figure out the magnitude of A cross B by doing this formula and then square rooting the square of each component. I would also be able to find the magnitudes of A and B, again square rooting the squares of each component, and so then I could isolate and solve for theta. That would be one suggestion for why I might use this formula. All right, so again, you know that I'm going to give you this formula on the formula sheet, but in other years, there is a memory trick for remembering this formula. I'm going to use it to help me kind of sort through finding A cross B in this first example. So the memory trick is that you write down, I'm going to use my black pen, you write down the coordinates of the first vector. So for us, it's A1, A2, A3, and then you write them down again. So I'm just stacking them vertically twice. And then off to the side, I do the same thing with the other vector. And then before I get started doing the cross product, I'm actually just going to cross off the first row and cross off the second row. So when you get used to this, you'll just know not to write that first row or that second or that last row. All right, so just moving over to our example, we're actually going through the investigation on page 405 in your textbook. It's going to give us the opportunity to practice this formula a whole bunch of times, and I encourage you to pause the video and do the calculations yourself and see how you did by restarting the video. We're going to go through all of these questions with the same vector A and same vector B. So they're listed here, and then I relist the same vectors throughout this note. The first question that we've got here is cross product commutative? And remember, commutative just means, can I switch the order? So does it make a difference if I do A cross B or B cross A? So we're going to figure that out. So I'll start with A cross B. So I've already got these stacked in the correct order. The A is on the left and the B is on the right. Notice that I am doing subtraction within each of the components. So I do have to make sure that I do this calculation multiplying, then this calculation, and subtract in this specific order. My result here for a vector is indeed a vector. This is an x component, a y component, and a z component. So when I write my answer, it should be in brackets with commas like this. So I'm going to write my answer here in brackets. I'm going to make them nice and big because there's going to be a bit of arithmetic here inside. So to find the x component, what we do is we start with a2 and we multiply by b3. I'm doing the cross product here. So a2 times b3. So in my vectors, a2 is here and b3 is here. So I'm going to get 4 times negative 5. And then I'm subtracting. So I'm just here at this step in my cross product. So now I'm going to subtract. I want a3 times b2. And notice that in this stack here, I'm just crossing up. So this kind of helps me remember the order of all of this stuff in the formula. So a3 times b2. So now I'm doing a3 times b2. So 6 times 2. That's just the x component. So comma, and now we're moving on to the y. So for the y component, what we're going to do is start where we left off here and do a3 times b1. Notice that that's the next part in my equation up here, a3 times b1. And so a3 times b1, so I get 6 times negative 1. Oops, not a comma. And then I'm going to subtract. So now we're moving on to this next part, a1 times b3. And notice it's making a cross just below the other cross that you just had. So a1 times b3, that's a1 and b3. So 2 times negative 5. Comma, and now we're going to move on to the z component. The z component starts with a1 times b2. So a1 times b2, notice that now I'm just going to start across right underneath. So you can see how this memory trick kind of helps me keep track of the order if I didn't have this formula. So if you're more of a visual person, you might do this anyways to help you kind of sort through this. So a1 times b2, I've got 2 times 2. And then we'll do a2 times b1. So that's a2 times b1. And I've got 4 times negative 1. And I'm subtracting that. All right, so now we'll figure out that arithmetic. So I've got negative 20 minus 12. Negative 20 minus 12, that's negative 32. And then in the middle here, I've got negative 6 plus 10, so that's 4. And then at the end here, I've got 4 minus negative 4, so that's 4 plus 4. I've got 8. Okay, so there's our answer for A cross B, but to find out if it's commutative, I also need to do it the other way around and see if I get the same answer. So I'm going B cross A. So for this one, I have to kind of go through this formula, but I'm switching all the A's to B, so it's kind of confusing. I'm going to go through B2 times A3, B3 times A2. So for my first one, I'm starting here with B2 and A3. And then I'm going to subtract B3 times A2. All right, for the next component, for the y component, again, I'm switching all the A and B letters. So I want B3 times A1, B3 times A1, minus, and the next one is A1 times B3, but I want to switch the letters, so B1 times A3. So we've got negative 1 times 6. And then the last one, the z component, we've got A1 times B2, but we're going to switch the letters, so B1 times A2. And then we'll subtract, and then the last one here, we're going to switch the letters, so it'll be B2 times A1. Close off that point. And so now we'll do the arithmetic here. So I've got 12 minus negative 20, so 12 plus 20, I end up with 32. And then here I've got negative 10 plus 6, so negative 4. And here I've got negative 4 minus 4, so that's negative 8. And so we see here that these answers are not the same. So cross product is not commutative. So the order matters when I'm doing cross product. What you might notice here, and we're going to summarize this at the end of the note, is that these guys are actually just the exact opposites. And that should make sense to us since the cross product formula is just a subtraction here, right? When I change the order of the A's and B's in each one, it doesn't make a difference because those are multiplications. But what I am doing is changing the order of the subtraction, so I get the opposite answer. So A cross B is actually the opposite of B cross A. Just the opposite direction, right? So in the picture here, if I did B cross A, I get like the vector that's coming down this way, that's perpendicular to the original B and A. All right, is cross product distributive over addition? So this time what I want to know is, can I take this A and distribute it into the bracket if there's an addition between these two vectors? The result then would be A cross B plus, and then distributing the second one in would be A cross C, like this. So I want to know, is this actually equal to this? Does it work that I can distribute that through the bracket? So we are using the same vector A and B as we did above, but we're adding on a new vector C to check this one. So first, going over A cross B plus C. So there's brackets here, so if I'm sticking with BEDMAS, I need to do the step in the bracket first. So remember to add two vectors. So the A cross is still there. To add two vectors, you just add up the corresponding x values, y values, and z values. So we're going to have -1 plus 4, 2 plus 3, and -5 plus -1, so -1. And so we end up with our A vector is 2, 4, 6 from right here. And then I'm crossing that with the vector 3, 5, and -6. So we're going to go through our cross product formula from above, and again, if you like, you can write out the steps and do the crossing off to the side. I would encourage you to pause the video and try that on your own, just to see how you're doing. So I'm going to cross this, I'm going to do the second coordinate here, 4 times -6 over here, so I get -24, and then I'm going to subtract the third coordinate by the second coordinate. 6 times 5 is 30. And then for my middle component, I'm doing the third times the first, so 18, and then the other way around, the first times the third, so minus -12. And then my last one, I'm going to do the first times the second, minus the second times the first. And then we'll just simplify this out. So you might notice that in this cross product, I skipped writing out each of the 4 components that I was multiplying, and I just did the multiplication in that and then just wrote the subtraction step. So a little bit different than how I wrote it up here. Here I wrote out all of the individual components. I'm fine if you skip to this, but I do want to see one step or the other. So either way I took 2 steps. You decide which version you like better. All right, the next one, so that we've got our answer for this one. We want to know, what can I do it in this order instead? So can I do A cross B, figure that out, and then add the answer to A cross C? So I have to do the crossing first, right? Multiplication first, and then add the final 2 answers. Now, don't forget that we actually already did this in part A above. So I'm not going to redo that work. I already have the answer to this. It's -32, 4, and 8. Oops. And then we're going to add the answer to A cross C. I don't have the answer for this, so I'm going to just scroll back up here. I'm going to do A cross C, and again, I encourage you to pause the video, see how you do with that. So here I'm doing, A cross C. So I'm doing 4 times -1, so it's -4, and then subtracting 6 times 3, so subtracting 18. And then for the middle one, I'll get 24 plus 2. That's the third times the first, and then the first times the third, and subtracting those 2 answers. And then for the last one, I'm going to do the first component times the second, minus the second times the first. All right, so we're going to figure out what that is. All right, so hopefully you came up with that same answer. Now we've got just an addition of two vectors. So here I'm just adding the matching components. So negative 32 minus 22, that gives me negative 54. Looks promising so far. Then the y values, we've got 4 plus 26, 30. And then finally the z value is 8 plus negative 10, that's negative 2. And we do have the same thing. So what we see here, I mean, we've only shown it with one example, but it does work in general. You could check it with all variables if you wanted, and that would prove your work. The cross product is distributive over addition. Okay. All right, the next thing that we're going to check is the cross product associative. So that means like if I have three vectors that I'm all crossing together, does it matter if I cross the first two first? Or what if I want to do the second and the third first and then cross it with the first one? Does it make a difference if I do in these different orders? So we're going to check this out. Again, the same three vectors that we were using before. So A cross B first and then cross with C. So again, remember that I already have this answer from part A. So I'm just going to write that down. I know that it's negative 32, 4, and 8. And then I'm going to cross it with this vector C. Okay, again, I would encourage you to pause the video and see if you can cross those out. Again, you might want to draw your little memory trick if that helps you to actually cross it out. You could even use a C here if you wanted, since technically the vector is called C. That's just a memory trick. So I'm crossing these two off, and then I'm going to go A2 to B3. So the second one to the third one. Minus, and then I go the third one to the second one. And then just continuing down, we're going to cross A3 with B1. Minus A1 with B3. It's a little bit tedious, eh? And then A1 with B2. And then we're subtracting A2 with B1. Okay, and all together we get here negative 28, 0, and negative 112. So hopefully you got the same answer. All right, next we're going to do A crossing with B cross C. But this time we're going to do B cross C first. So A is just hanging out, and I'm going to figure out what B cross C is. Fortunately, we haven't done that one yet. So I'm looking at B and C up here, and I'm going through the same process. I'm going to go A2 times B3. I'm just thinking of this as my A because it's the first one. So 2 times negative 1, and then 3 times negative 5, but I'm subtracting that. And then working on the third one with the first one. And then the first one with the third one. And then the first with the second. And then the second with the third. Whoops, minus 6. Oh, wait, the second with the first, sorry, 8. You can see that it's really easy to make slips with cross product because you kind of go cross-eyed looking at all these different numbers and what order to get them in. So remember, again, that's where showing me your steps will help me figure out how large of an error that you've made, and maybe it's just a little slip. But if you show me no steps, I don't know if you totally misunderstand the concept. So we've got negative 2 plus 15. All right, so now we're going to cross this with A. Sorry, I should have probably written that in there. We're going to cross these two vectors together. You don't need both of these lines, obviously. I would have just gone straight to this one. All right, again, I would suggest that you pause the video, try the cross product on your own. We're getting lots of practice in this lesson. We're going to go the second with the third with the second, is negative 1, 2, 6. And then when we do the subtraction here, we're going to get 82, 100, and negative 94. And what you should notice is that is not the same as before. So it actually makes a difference if I do the multiplication of the first two things first or the second and the third thing first. That makes a big difference. So no, cross product is not associative. So this is different from regular, sorry, my spelling, I'm trying to talk at the same time. This is different than regular multiplication, right? All right, for the last one that we're going to prove here, we're going to choose a scalar k. So you get to pick any number that you want. It could be negative, it could be a fraction, it could be a big positive number. You're going to pick a number for k, and you're going to figure out what k times a is. So for k, a, that would be k times the vector 2, 4, 6. So you've got your k number in mind. And then you're going to multiply it through the components. So you'll end up with 2 times your k number, 4 times your k number, and 6 times your k number. So now you're armed with this new vector. We're going to figure out, well, what is a cross k a? So my a vector is 2, 4, 6. And then you're going to write down your ka vector. Maybe you chose half for k, and then you would end up with 1, 2, and 3. Or maybe you chose 100, and you got 200, 400, 600. Maybe you chose k as negative 1, and you got negative 2, negative 4, negative 6. You got some sort of other vector here. So I want you to pause the video and go off and do the cross product of those. Everybody's got a different answer, so you got to try it on your own. I'm going to do it with the k variable in there, so I'm going to do the second times the third, minus the third times the second. And then for the y variables, I'm doing the third times the first, minus the first times the third. And then the first times the second, minus the second times the third, or the second times the first, sorry. And then I'm going to simplify. So you might notice here that I've got 24k minus 24k. And then I've got 12k minus 12k. And then I've got 8k minus 8k. And all of those are going to come out to 0. So this is a special property here. I've gotten the 0 vector when I did a crossed with a scalar multiple of k. Now when I use k times a, what you should realize is that these two vectors, a and ka, are collinear, right? I've just got a scalar multiple of the original vector, so I'm not changing the direction, I'm just changing the magnitude of that vector. So what it's saying here is if you cross a vector with a scalar multiple or another collinear vector, you're going to get the 0 vector. So and you can kind of imagine that, right? So if I've got a, and then I've got ka, when I try to find a vector that's perpendicular to both of these guys, well, there's actually an infinite number of vectors here that are going to work, and there's no angle in between. If I think about the magnitude back here, if I think about the magnitude, sine of the angle in between those two is 0 degrees. And when I do sine of 0, I get 0. So I'm going to get 0 times who cares what the magnitude, and who cares what the magnitude is. This whole thing is going to equal to 0. So the magnitude here of my cross product will be 0. And that's why I get the 0 vector there. All right, so let's review some of the properties of cross product. So one of the things we need to notice here that's different about dot product is the result, or the answer, is a vector this time. So I cross two vectors and I get a vector as an answer. The cross product must be done in 3D, so we don't do this one in 2 dimensions. Vector A and vector B that I'm crossing must create a plane, and the cross product is perpendicular to the plane. So whenever you have 2 vectors, in 3 space, they do create a plane. You might remember the plane is like the big flat sheet of paper that extends in all directions for infinity, and they do uniquely create one. We're going to talk more about planes in chapter 8. Something else that we figured out is that if I cross 2 vectors in the opposite order, I actually get the opposite vector to each other, right? So all the components are going to be the negative of each other. Here I also figured out that I can distribute across addition, so I was allowed to do that. And then here with the scalar multiplier, we didn't talk about this one specifically, but I'm just going to tell you, if you want to do a scalar multiple of A, but you're crossing with a different vector B, so this is not like what we just did up here. These are 2 different vectors, one of them's got a scalar multiple. You can pass that scalar multiple around. So I can change the magnitude of A, or I can change the magnitude of B, or I can just find the cross product and then change the magnitude of that afterwards. It doesn't matter where I throw that scalar multiple, it will work. And so normally we kind of use that to pull it out front and just write the A cross B to simplify things. And then finally, this one, really important, if A and B are collinear, then the cross product is going to be the 0 vector. All right, enjoy your homework, guys.